Question number 32. The potential difference across the metal wire is kept constant. You have a metal wire, potential difference is kept constant. Okay. If it is kept constant, I know V is equal to I into R. Length L and diameter D of the wire are both varied. Now, if L is varied and D is varied, what can change? R can change, right? So, R is equal to rho L divided by A, which you already know. Rho is the specific resistance. Rho into L divided by pi into D square by 4. D square by 4 because it's R square over here. Pi R square, so I am writing it like this over here. Okay, and then the type of metal is kept same. And then how is the current in the wire related to L and D? How is current in the wire related to L and D? Let me plug in this value. V is equal to I into rho L divided by pi D square divided by 4. So therefore, current I will now be equal to V into pi by 4 multiplied by D square divided by L. I get this value. Now what can you see here? You can see that I is proportional to D square and I is inversely proportional to L because all these are kept constant. So now let us look for this I proportional to D square. Current I is directly proportional to L? No. Directly proportional to L? No. Inversely proportional to L? That's right. But directly proportional to D? This is also incorrect. So D is the right answer. Inversely proportional to L and directly proportional to D square.